Alright, so today we're going to look at section 1.5, which is on transformations. Now specifically, we are going to focus on transformations by looking at parabolas, okay, or quadratics. We're going to look at transformations through every chapter we do in algebra, right? Transformations, there's four basic ones. There's shifting vertically, shifting horizontally, that's two. Then there's stretching vertically, and stretching or compressing horizontally, that's four. We can do this with parabolas, we can do it with square roots, we can do transformations with every function we study, okay, and we will. But once you learn the general pattern of a transformation, it's the same for everything, okay? You just have to learn like, oh, okay, if you put the number here, it shifts it up. If you put the number here, it shifts it left. We just got to learn what goes where. All right, so quadratic functions are usually written in this form, ax squared plus bx plus c. At least when we want to solve them, we usually get them equal to 0. And a, b, and c can be any real number that you want. Except a can't be 0. Because if you make a 0, don't write this, but if you make this 0, you just wiped this out. Do you have a quadratic now? No. Now you have a y equals mx plus b, basically. You've got a line. All right? Now, could b be 0 or c? Sure. You could have an equation like y equals 3x squared. That's it. That's a quadratic. Okay, so I'm just going to graph y equals x squared. I think we've done it before. Let's just graph it real quick. Let's type in x squared, zoom 6. That's what it looks like. Okay, it's a parabola with the vertex at the origin, and it's a minimum. Now, I want to take a look at what happens if I plug in negative x in place of x, okay, in parentheses. Right? So it's basically like I'm taking this and filling it in for x. Let's see what happens. I'm going to take that, and I'm just going to draw it down below in red. Negative x squared. Okay. So the negative caused, how would you describe what happened? It flipped. Some people said reflection. One more thing I need to say. Reflection or flip.
Over the x-axis.
Over the x-axis. All right. Now, if we do that a little differently, I'm just trying to show you like what a negative does. Let's take and go like this. Negative x squared. The blue one and the red one came out exactly the same. Right? There was no difference. No, was it the blue one?
Wait, what did you just say?
The red one and the black one came out exactly the same. All right, so that was the same. Let's try this. Let's go and put a negative x squared, but this time I'm putting the negative out in front. So it's not in the parenthesis, it's outside. Let's watch what happens this time. So there's the original. There's the one where I put in a negative inside the parentheses. And now it looks like that. Okay, so depending on where you put a negative, we can cause different things to happen. Negatives usually cause flips. Right? I can't really flip this one over the y-axis. It's not really a good example to do it because what would happen if I flipped this parabola over the y-axis?
The line has to no longer be a function.
It would what? It would look the same. It would be the exact same graph again, and that's because the y-axis is a line of symmetry. Okay? So I think I said that already. Parabolas always have a vertex. The vertex can be a low point, which we call a minimum, or a high point, which is a maximum. Just depends on which way the parabola is facing. Okay, so the vertex could be the highest point if you flip the parabola. Okay, the x-axis is not a line of symmetry for a parabola. Ever. It's always, line of symmetry is always up and down for a parabola. Always vertical. Okay, let's graph these three different things and see what happens. So what I'm trying to show you is basically what happens when you put a number in front of x squared. It's going to cause a transformation. Let's see what it does. Okay, so we've got, we'll keep x squared. And let's put in 1/3 x squared, just like that. So there's the original. Now watch what happens when you put in 1/3. Okay. Now let's do 2. Let's put in 2x squared. Okay, if you think about it vertically, right? Imagine that all these parabolas are glued right at the origin. They can't move. If you take the blue one and you pulled up on the sides, it would get skinnier, right? Like if you had like a piece of Play-Doh and it was stuck and you pull up on it, as you pull up, it gets thinner, right? That's exactly what happened to the one in black. We're going to say that it's stretched vertically, okay? It got thinner. Where the one in red, think of it as like getting squished, right? If this piece of red was like a piece of like flexible steel, right? It was glued in the middle and you started pushing down on the sides, it would cause the parabola to spread out, right? It would get wider. So we say that it compressed vertically, right? So we always describe it in terms of what it's doing vertically for this situation. Either vertical stretch, or you can say vertical compression, or some people say shrink. So, I just explained to you the effect of changing A. But specifically, if you put in a number that's bigger than 1 in front of x squared, that will cause your graph to stretch. Bigger the number, bigger the stretch. So if you put in like 20x squared, it's going to look very, very skinny. Now, I'm still sticking with positive for now. You guys already kind of saw what a negative does. We'll go back to that in a minute. But if you put in a fraction in front of x squared, okay, a fraction less than 1, but still more than 0, that's going to cause your graph, it gets shrunk vertically, or it shrinks vertically. Okay? The smaller your fraction, the more it shrinks. So if you put in like 1/10, that's going to look really squished. Okay, it's really going to spread out horizontally. Okay, so any question on that idea? And that's true for everything, right? If you had this function versus this function, the one on the right is vertically stretched by a factor of 3. Anytime you put a number in front of a function, it's always a vertical stretch or compression. It just depends on what number you put. Now, maybe I don't even need to draw this, but what happened when we put a negative in front? It flipped over x-axis. So the negative causes the graph to reflect over the x-axis. And that is true for any function we ever study. If you put a negative in front of the entire function, it's a mirror image over the x-axis. So if you had a function that looked like this, which is a square root function, and you wanted to mirror image it, all you'd have to do is put a negative in front, and it would flip it. So, what you're going to see a lot with transformation problems is they're going to say, okay, here's the one you started with, here's the one we're going to draw, tell me the steps to draw it. Okay, we'll look at the two things that are happening. Now, when we get into problems that have multiple transformations, yes, there is an order you should generally name them in, which I think I'm going to give you that order in a little bit. But this is the only one that we've really looked at so far, number 2. Vertical stretching and shrinking. All right, so one thing you want to be careful about here is the negative and the 5 are 2 separate things. This does something, this does something else. So this is a 2-step process, okay, to change, if you wanted to call these something different, y1 into y2, or y2 into y1. So step 1, what is the 5 going to do? Just the 5.
It's gonna shrink.
So it's going to be what kind of shrink?
Stretch.
Shrink or stretch? Which one?
Stretch.
So it's going to stretch which way? Vertically, because we're going to do horizontally eventually. So this is a vertical stretch. And then you have to say by how much. Everything is stretched vertically by a factor of 5 times. Or just by a factor of 5. So basically that means if you gave me a bunch of coordinates for a parabola and I wanted to stretch them by a factor of 5, I would multiply all the y values by 5 and leave the x's alone. And that would stretch everything out. So vertical stretch by a factor of 5. And what's the second thing that we're going to do? Flip it. Flip it over the x-axis. Yep. Or reflect, same thing. Reflect over x-axis. Now, sometimes, depending on the transformations, it's like PEMDAS. The order you do it in does make a difference. Like if you shift and stretch, or stretch and shift, that can be different results. So we got to get a certain order, and I'll show you that when we get there. So discuss order. I told you there's a certain order we have to follow. Okay, let's try this one. So this one's a little different. We're not multiplying by a number in front. We're adding and subtracting a number on the end. So we're going to try it on the calculator and see what happens. Does anyone have a guess what that +2 is going to do?
Shift it up.
It'll be the one of the coordinates for the vertex.
So I'm looking for the transformation. Your options are it's either going to stretch vertically or compress, which we already did that. It's either going to shift up or down, could do that. Could shift left or right, or it could stretch left or right. Yeah?
It's going to shift up.
Okay, so let's take a look. If we put in a +2,
Vertex is gonna be on y.
so let's type in x squared plus 2. So there's your original. And then x squared plus 2, it does shift it up by 2 units. It's the exact same parabola, just shifted up. All right. So I don't think we need to do the second one. You can probably guess. So how can we get y equals x squared plus 2? So to get y equals x squared plus 2, shift y equals x squared up 2 units. That's it. That's how you get it. Now, to get the next one, y equals x squared minus 3, what do you think you would do to y equals x squared? Shift it down. Shift y equals x squared down 3. So what do you think controls whether it goes up or down?
Minus or plus.
Yep, minus or plus. Okay, so these are both examples of vertical shifts. These are rigid motion transformations. Rigid motion means you're not distorting your image. You're just taking and moving it somewhere. There's no stretch happening. So rigid motion. And if you have y equals x squared plus k, could be plus or minus, it depends. If k is greater than 0, so If that part right there is greater than 0, it's going to shift up. If that part is less than 0, it's going to shift down. Now, why did I put shift down absolute value of k units?
Because it can't shift down a negative number. Does that
Right.
mean it's going up?
Yeah, that's kind of weird if you say shift down -2. So do you mean down 2 or do you mean up 2? So down takes care of the negative. So you either shift up 2 or you shift down 2. But you don't shift down a negative amount or shift up a negative amount. That's weird.
Could you just shift -2 and write it like that? Or
You would
shift-
want to always give me the direction.
Okay.
So shift up 5 units, shift down 6 units. Same thing when we get to left and right. Shift left 5 units, shift right 5 units. So for a transformation, there's always 2 parts. What's the transformation and how much? Okay. Let's look at this one. Now, little difference from what we just did. What's the difference? Still adding and subtracting. Before it was on the outside, now it's on the inside. So what do you think a plus and minus on the inside is going to do?
Shift it left and right.
It's going to shift it left and right. Which way do you think minus is going to go?
Right.
I heard some people say left, I heard some people say right.
It's
Right.
Oh.
Let's see who's right. Huh, okay. So let's type in x minus 3. So you would think, okay, minus, negative numbers, right? Negative numbers go to the left. But when you graph it, it actually shifted it to the right. So this is one that's a little different. Okay, so minus is going to shift to the right. If I put in a +2, okay, remember normally it would be at the origin. With +2, it moved 2 units left. Okay, so let's write this one down. So to get y equals x minus 3 squared, shift y equals x squared. How many did it, which direction did it shift?
Right.
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 So shift y equals x squared, right 3. All right, and then pretty much the same thing again to get y equals x plus 2 squared, shift, and which way did we shift that time?
Yeah.
Left, how many? 2. Yep. So shift y equals x squared, left 2. So this is another rigid motion transformation. Okay? It's not distorting it, it's just moving what you have. So since this one it's kind of backwards from what you would think, you just have to remember that plus shifts left, minus shifts right. Another way you can remember it, I guess if it helps, is think about the number after the minus sign. Okay? If the number after the minus sign, so let's look up at this one. Just the number, not the sign. The number after the minus sign is a 3. Positive 3, right? It goes to the right. So if the number after the minus sign is greater than 0, you'd shift right. If you want to think about, like, let's look at this one. Think about it like this. X minus -2. Okay, if you want to think about it, okay, the number after the minus sign, well, there is no minus. It's a plus. Well, you could make it a minus by doing x minus -2. Now, look at the number after the minus sign. -2. -2 goes left 2 units. All right? So I would pick one way to think about it. Either think about it as the number after the minus sign, or just remember when you're looking at it, it's the opposite. So you can think about it either way. If you try to think about it both ways, it gets confusing. Pick one. Honestly, I usually just look at it and think, okay, plus always shifts left and minus always shifts right. I don't usually think about it as the number after the minus sign. But that's one thing your book mentions. So you can write that if you think it's helpful. If not, just remember it the first way I say it. So, if I did this, right, this has got all three transformations in it. Vertical stretch, horizontal shift, vertical shift. There's only two letters there that affect your vertex. Out of the A, the H, and the K, which two would affect where your vertex goes? Yeah?
H and K.
H and K, all right? That's the two that would affect it. So the vertex is always at H, comma, K. Now, out of the H and the K, which one would affect the line of symmetry? Think about how the line of symmetry is normally, and then think about which transformation would affect that. Yeah?
H.
Let's see. H, yes, shifting left and right. K has no effect on the line of symmetry because the line goes up and down forever. So if you shift your parabola up 2 units, still the same line of symmetry. It's only if you shift it left and right. Okay? Now what's the equation for a vertical line? Well, never mind. I told you. So it's x equals. So your line of symmetry for a parabola is x equals h. Yeah.
So we have you have that negative over the h right there, right? Is
Yep.
it the opposite if you're in a is it opposite of negative h, so it'd be a positive h?
So like if you had a number in there, like let's just fill in numbers.
Yeah. So
This would, go ahead.
so for the vertex, would it be -4 or +4?
So the h is just 4.
Okay.
It's just the number after the minus sign. That's something you gotta be careful with. Yeah. The h is just the number after the minus sign. Because think about it. Minus is gonna shift it right 4 and up 5. So if you shift right 4, your vertex is gonna be 4, comma 5.
So if it was a plus, it would be -4.
Yeah. If that's a plus, now your vertex is gonna move left 4 units and up 5. So it's -4, comma 5. Yeah. Yeah. So you gotta be careful. So that's why if you write it, like if you think of it like this, the number after the minus sign is your h. The number after the minus sign is -4. So you gotta be careful with that. Yeah. Okay, so let's find the vertex and line of symmetry here. Okay, what is my vertex? Yep.
-2, -3.
Right, it's gonna shift left 2, down 3. So -2, -3. And the equation for my line of symmetry? Yep. Adrian? X equals -2. Yep. It would have been at x equals 0, which is the equation for the y-axis, but we shifted it left 2 units. So everything shifts left, including the line of symmetry. All right. So now we're going to get into where order starts to matter. So you might want to leave a little space. Probably only going to need about 3 or 4 lines to do example 6. But after example 6, I would put this down. So when you're performing transformations or writing them down, this is kind of the precedence that they have. Horizontal shift always comes first. Then vertical stretching or shrinking. So it's like you start inside the parentheses with your shift, and then you see if there's a number outside for your vertical stretch. Now, we're not doing it in this section, but we could do horizontal stretches. That would be a number right next to the x. We're not doing that with parabolas, though. We could, we're not. Okay, so you're not going to have to worry about horizontal stretches. If you were, they would go right here. I can write it in if you want, but you're not going to see it in this section. You will later on. Horizontal stretches would go right after step 1. Yep.
Is that kind of just like a universally agreed on thing, or is it mathematical that is that way?
No, it's like, yeah, no, it makes sense when you
Okay.
start to graph things, yeah. Yeah, it does make sense why it's this way. Okay, so horizontal shifting, you're not gonna have to worry about horizontal stretches today. Then you go to vertical stretching and shrinking, reflection in the x-axis if it happens. Okay, you'll know if it happens if there's a negative. And then vertical shift is always the last thing that you do. Okay. So let's look at this one. How many transformations are happening to change x squared into 5x squared plus 4? 2. Is there a horizontal shift? No. Is there a vertical stretch or shrink? Yes. Which one? Stretch. Vertical stretch. By how much? 5. Everything's stretched out 5 times as much. Factor of 5. Is there a reflection in the x-axis? No. You would have to have a negative in front of the 5. Is there a vertical shift?
Yeah.
Yep. Which way? Up. How much? 4. So shift up 4. You don't have to say vertically shift up 4 because I know that up is vertical. So shift up 4. Any questions on that? Okay. Okay, another one of the same kind of things. Describe how to change x squared into negative 3x minus 1 squared plus 4. First, how many transformations?
4.
4, yes. There are 4 transformations. What's the first one?
Horizontal.
Yep, horizontal shift. How much? Which?
By 1 unit.
Right one. So shift right 1. Next thing.
Vertical stretch by 3.
Vertical stretch by a factor of 3. Vertical stretch. Factor of 3. Of 3. Let's see. Next thing. Yep, it has a reflection. So reflect over x-axis. And the last thing.
Vertical shift up by 4.
Yep, shift up 4. Okay, so that one had everything. I think, yeah, we weren't missing anything in that one. Technically, we could have had a horizontal stretch. We could also do a horizontal reflection. I told you you don't have to worry about those 2 today. I'm not even going to write them in on the chart. Yeah.
What would happen if you did that out of order?
If you did it out of order and you were actually drawing it, you'd get a different picture. Think about like, let's just do it with a single coordinate because that's easier. Let's take the coordinate 2, 2, 5. And let's do 2 things to it. Shift up 6. And then let's do vertical stretch by factor of 3. Vertical stretch by 3. So I'm not saying which order to do them in. Let's do both. So let's shift up 6 first. If you shift up 6, what does this coordinate become? 211. 211. And now let's stretch. If you stretch it by a factor of 3, what does it become? Remember, which way are we stretching it?
So over at 14, 2, 14.
Well, what kind of stretch is it? Vertical, and stretch is a multiplication.
Okay, so 233.
233. So that's where that point would go if you did those transformations in that order. Now let's switch it. Let's stretch it first. Where does that point end up if you stretch it? 215. And now let's go up 6 from there. 221. So the points don't end up at the same spot. Now, if you had a shift up and a shift right, it technically wouldn't matter which one you do first. If you go up and right or right and up, you get the same result.
It's kind of like PEMDAS.
Yeah, so where it starts to matter is if you do 2 transformations on the same axis, like a stretch up and down and a shift up and
Couldn't
down.
you reflect on the x-axis and then horizontally shift also in either order?
If the transformations affect different axes, yes. It's when you have 2 transformations that affect the same axis, like a stretch and a shift.
Okay.
That's when it starts to matter. Yeah.
Would it matter if you did vertical before you did horizontal?
Technically no, as long as you do the vertical ones in the right order and the horizontal ones in the right order.
Okay.
Yeah, because they're 2 totally separate things. One affects x values, one affects y values. All right, so all the equations we've done so far have been in standard form. Standard form makes it very easy to identify stretches and shifts. Now, let's say that I took, let's take this one, -3 x minus 1 squared plus 4. Now, if somebody FOILed all that out, they would get x squared minus 2x plus 1 plus 4. Then they distribute the -3. -3x squared plus 6x minus 3 plus 4 is how much? Plus 1. Now, if I gave you that and said, how would you get from y equals x squared to what I've circled? It's the exact same steps. The issue with what I've circled is it's a lot harder to see those steps. You can't see that you've shifted up 4, right? You can't really tell that you've done a vertical stretch by a factor of -3, right? It's all been FOILed out, which is not what you want. So, if you get a problem like this, we have to change it back to something like that. Okay, that's the first step. And to do that, we have to complete the square. Right? So if you're given an equation that was all FOILed out, like I showed you, you've got to undo it. And the way you undo it is completing the square. I'm not really going to write down all the steps for how to do this. I'm going to do an example so you can see the steps. But in Algebra 1, I would go through and spend like 40 minutes teaching how to complete the square. But I'm just going to show you with an example.
Is a question like in this form going to be on the test or the homework?
Yeah, you're definitely going to have one in the homework. You could have one on the test too. You wouldn't have more than probably one of them because they do take a little longer, but not. We're talking maybe an extra 60 seconds to go through and complete this way. If you know what you know what you're doing. All right, so the example we're going to work with in number 8 is 3x squared plus 12x minus 18. I just want you to describe all the transformations. Shifting, stretching. Okay, is example 8 in the right format? To be able to easily describe all that stuff.
No.
No. All right. So we're gonna fix it. So it is. Does everyone have the? Well, I didn't really even give you steps there, but everyone have that. Okay. So to complete the square, first thing you have to do is make sure that the equation is. Well, we can start with it like that, but we got to move the constant to the other side. So we can start with it like this. where you basically get it equal to 0 if you want. But then you've got to put the constant on the other side. All right. So what I think I'm going to do it this way. Doesn't really make a difference. I just like to put the constant on the right. So that's step 1. So I'll just write what I did. Put constant on other side. Next thing, to complete the square, you can only do it if the coefficient of x squared is a 1. Is the coefficient of x squared a 1 here? No. No. So then we can factor out the coefficient. So factor it out. You don't have to factor it out of the right. The right is on the other side. It's kind of all by itself. So, you know what? You don't have to leave space here. I left space because if I was actually doing this problem, I would write something in on that step. But I'll write it again as a whole nother step. Yeah?
Why don't you factor out by 3x?
Because you're trying to complete the square and you want this to eventually, it's going to have a variable in it. So if you factored the x out, you would have no variables left inside the parentheses. And you want to leave the variables inside parentheses.
What if the 12 was a 13 and you couldn't factor out, like...
Well, now then you're going to get into fractions. It gets really messy.
So that probably wouldn't be on the test.
Probably not.
Okay.
So if you have fractions, you're going to get like 12 13ths
Right.
or 12 thirds or, well, 3 12. So you're going to get messy fractions. So factor, or actually I'll just say make x squared have coefficient of 1. Okay, now we're ready to complete the square. So there's 2 steps to completing the square, and it all is controlled by that number right there. Does anyone remember the 2 things you have to do to that number? So that's the coefficient of the linear term, okay, because that's with the x. So I'll write what to do, and then you can tell me what it would be. So take half, how can I write this short? So you want to take half of that number and square it. So take half of coefficient of linear term and square it. Now, it's as short as I can write it. So take half of the coefficient of the linear term and square it. So half of 4 gives me 2 and square it. So in this case, it just happened to be the same. Now, you just added something on the left. It's very important when you complete the square that you keep the equation balanced. What did I just add on the left? 12. Right? I really added 12. Yes, you wrote plus 4, but anything you put inside these parentheses is tripled. Okay? So you have to add 12 to the right. That keeps the equation balanced. Now, if you've done this part in the parentheses right, this should factor very nicely. And it should factor into something times something where those 2 things are the same. Like x plus 9, x plus 9, or x minus 12, x minus 12. Okay, but it should factor very nicely. Yep.
So how do you get the 12?
Because on the left, I added 3 times 4. Because anything I put in those parentheses is really tripled. The mistake people make there is they put plus 4 on the right.
So you just like moved down the 4x, and then the 4 that you added in the parentheses is like taking half the code.
Yep, it's just a coincidence that this is a 4 and this is a 4. Not the best numbers, but if this was a 6x, half of it would be 3, and then squared would have been 9. Then they would have been different. So how does x squared plus 4x plus 4 factor? Yep.
X plus 2.
Yep, x plus 2, x plus 2. So we're going to just say x plus 2 squared, and now you can start to see your horizontal shift. Okay? You've got your shift, you've got your stretch. We almost have the vertical shift. We have to put it back on the other side. So what did we do there? We factored. No, we didn't factor. Yeah, we factored, I guess. Yeah. So we factored at that step, and now put the constant back on the other side. Constant back with all its friends. Constant back with minus. Or I guess you could say get equation back equal to 0. Same way.
So should it always be plus plus, like above?
Will it always be plus plus?
Yeah.
No, it could be a minus minus. It could be a minus in here. Like if this was a minus. Now it would still be a plus 4 here, but it would factor as x minus 2, x minus 2.
So, okay.
Yeah.
But it should it? Oh no, okay, no.
So it's either going to factor as plus plus or minus minus. This one was a plus plus. So 3x plus 2 squared minus 30, because we're bringing the 30 back to the other side, equals y. So there's my equation. Now, how many transformations do I have? Let's see, 1, 2, 3. 3 transformations. What's the first one? How much?
Left by 2.
Yep. So shift left 2. Second thing?
Stretch.
Which way?
Factor of 3.
So that's how much? Which
Vertically.
vertically. Vertical stretch by factor of 3. Which you could kind of tell that right away, even after the first step. So you can kind of figure that one out. And then last step. Shift down 30. Did they ask for the vertex? No, what is the vertex though?
-2, -30.
Left 2, down 30, -2, -30. Okay. Keep that in mind, because I'm going to show you a shortcut. If all you had to do was figure out the vertex, you actually don't have to do any of this. If you want to know the transformations, yes, you have to do this. But if all you wanted to know was the vertex, there's a way to get it from the original problem. So, when it's all FOILed out, you have it as like a squared plus bx plus c. So let's look at ours. 3, 12, -18. Let me just write those
That's
down.
like easier though.
3, 12, -18. If you want to know the vertex, you can leave it the way it is and use this formula. I'll do the x just to show you. -b over 2a. Does anyone remember what was the x value of our vertex? -2?
Yeah.
All right, let's try this. -b. So -12 divided by 2 times 3.
6.
6. What's -12 divided by 6? -2. There's your x coordinate of your vertex. So you can get the vertex by just using that formula. And the line of symmetry is just the first part of the vertex. Okay, not a formula that I really remember very often, but it's there if you need it. This I kind of went over with you in the homework, so I'm not going to do it on the calculator right now. How to find the zero of a function. So anytime you set a quadratic equal to 0 and solve it, that's what you're doing. You're finding the zeros. It's a value for x such that when you plug it in, you get 0. Now, if you think about a quadratic, in general, it could look something like this in terms of how many times it crosses the axis. Maybe like this. Or like that. So quadratics can cross 0, 1, or 2 times. And if you want to know very quickly how many times a quadratic will cross the x-axis, not where, just how many times it crosses, you can do out the calculation b squared minus 4ac. Does anybody recognize that?
Isn't that in the quadratic?
Yeah. It's what's under the square root in the quadratic formula. If what's under the square root comes out negative, think about taking the square root of a negative. That's imaginary. You can't do it. So that means it would have no places where it crosses the x-axis. No zeros. If you take the square root of something that comes out exactly 0, well, think about if you take the square root of 0, how many answers there are? 1. If you take the square root of something that comes out greater than 0, like 4, there's 2 answers, 2 and negative 2. So this is a quick calculation to tell you how many times a parabola crosses the x-axis. Whether it comes out negative, 0, or positive. I'm going to hold off on that one. So in the homework, you're going to have a problem about like a fencing thing. If we get stuck on it, we'll just do the word problem in class tomorrow. But that's it for that.
The zeros is the same thing as like roots, right?
Yes. Finding zeros means finding roots, which means finding x intercepts. All means the same thing.
This is the b squared minus 4ac thing called the discriminant.
Yes. Yep. Technically, that is called the discriminant.
Okay.
Yep. Very good. Okay, so homework tonight is just one page, but it jumps around because I think there's like 70 problems in the section, so I just gave you a couple of each to try. So it's 1, 2, 7, 8, 10, 11, 16, 18, 21, 22, 28, 33, and 40, 41, 44, and 60. And we'll take a look at those problems first thing tomorrow, and we have our first test on Friday.